All right, so similar to what we were doing with 5-4, we had the sum and difference formulas. Now we're looking at double and half angles. So sum and difference, we were able to say, if I wanted to know what cosine at 15 degrees was, I can do 45 minus 30. Okay. Now, if I want to know something, again, with looking at, and we're going to do it towards the end, as weird as it sounds, something like sine of 22.5. What does that kind of trigger in your mind if you think of 22.5? You're looking at trying to figure out what it equals. Which formula would you use here?
Can you repeat the question?
Yeah.
Okay. When we were doing sum and difference formulas, if we wanted to know cosine of 15 degrees, we used 45 minus 30. What if I'm telling you to evaluate sine at 22.5 degrees?
Sine theta over 2.
What would theta be?
45.
45. Okay? So these are those angles that are not on our unit circle that we cannot use our left hand to find, that these formulas will help us do. Now, technically, I could find cosine of 15 degrees also using this same formula here and having theta be 30, right? Would I want to use this compared to the formulas we did the other day? No, because this one has a radical, which means I'm going to have to rationalize and do all the other things to it. Okay, so if I have a choice, which I do on a multiple choice test with the state, I'm probably not going to use this one. All right, so, but those are probably going to be given to you not more with the angles, but with the triangles that we were doing. Okay. All right, so let's check this one out first. Whoops. So they're telling you what sine equals, and they're telling you that theta lies in quadrant 2. So what does that tell you need to do? Draw a triangle. And what's our missing side? Which is number-wise.
12.
Close.
Yes.
You're right with 12, but where are we located?
Oh, sorry, negative.
Okay.
Isn't this a standard type of triangle?
I'm sorry?
Isn't 5, 13, 12 like
Y'all are my group that didn't have geometry all the way through. Some of y'all. So I have to assume, let's go back to the basics of diagram theorem and stuff like that. Like the 3, 4, 5 triangle, and then yes, the 5, 13, and 12. Okay, so I'm on a test, and let's say I accidentally made that same mistake where I forgot my negative. I'm gonna miss the formula problems from here on out, and all it is plugging them in. So when I have a choice, which I do with cosine, and we'll get to that on part B, I'm gonna choose the one that has the trig function they gave me, okay? Because I know they did not make a mistake. If they made a mistake here, then the answers are gonna be wrong as well, okay? So when of course I can't do anything about sine 2 theta, but at least when I'm working through cosine 2 theta, then I know if they gave me sine, I'm gonna use the formula that involves sine. Could you use any of the three of them? Absolutely. But then I know for sure I can't make a mistake unless I'm making mistakes with computation afterwards. Okay, so sine 2 theta. That's just 2 cosine theta sine theta. So what is cosine theta at this angle here? What does that equal? Good. Good news, they gave us sine theta, but it's 5/13. So go ahead and reduce that without a calculator. That's the hardest part about this test. You're gonna get to experience the 4-function calculator that you're gonna have on your state test. Y'all have had calculator, non-calculator tests with the graphing calculator, but now you're really gonna experience that little thing. Go ahead and reduce that. Some of y'all have moved on to cosine. All right, so I saw on a couple of y'all's papers where you put 2/1. That's helpful. So when you're distributing through, you're not multiplying it to all the things. Personally, how my mind works, I see the 2 times the 5, which gives me the 10. So I know that's negative 120/169. So like I said, on cosine 2 theta, I'm going to use the trig function they gave me. I know they haven't made a mistake on their sign, so I'm going to keep it that way. So 1 minus 2 sine squared theta. And go ahead and reduce that one as well. Don't forget your order of operations. So with order of operations, I have my 1 minus 2, and I have my 25/169. Then I can do my 2 times my 25. Common denominator, what's 169 minus 50? 19. Now, if I am doing the typical book work where they like to give you 3 questions in one, or like 7 questions in one, and they're having you answer this in this order. What's another way to say tangent? Sine over cosine. So when you work through tangent, notice what you could have done with your 2 solutions already. All right, so let's set up tangent. So 2 of tangent are opposite over adjacent. And go ahead and reduce that as well. Hardest part, like I said, is not setting it up because you're given the formula. Is just reducing good old adding and subtracting, multiplying and dividing fractions. I'll try to reduce the whole thing. To reduce that before. So think about 144. Remember those old rules? Don't forget the negative. You're gonna push it up. Okay, either way, you're multiplying it, doesn't matter. So then that's easier to multiply than that, right?
Yeah.
How many of y'all, after multiplying the 2 to the 5, reduce 10 over 12? Did it make it harder on you later?
No.
No? Good. Me personally, if I had 10 over negative 12, and because I'm recording, I'm gonna have to get creative on how I write all this in here. So we have 1 minus 25 over 144. So for me, when I start to look at my denominators, if I go ahead and reduce the 12 and the 10, that'll give me the 5, 6. I feel like I can work better with 12 and 144 as opposed to 6 and 144, which is fine. I mean, you can reduce, but I know in my mind that 12 and it's just that number sense again. But if you don't catch on to it, it's not like you're gonna miss it from there. Okay, so we get 10 over negative 12. This becomes, what's 144 minus 25? 119. So that if we multiply by the reciprocal, so So looking at there's that number of cents again that I was looking at that I can say, well, I can change this, like the old school math you used to do in elementary. 10 times 12 is a whole lot nicer than 10 times 144 and then 12 times 119 and then reducing that. Okay, so we have our negative 120 over 119. So let's look at our solutions here. We've got negative 120 over 169. We got 119 over 169. And we've got negative 120 over 119. So if they made you do all three of them, then that's different. Then I could say, oh, well, sine, if I put that over that, multiply by the reciprocal, I'm going to get the negative 120 over 119, which I did. Okay? Any questions on that? Okay? So try one all the way through. Be thinking if there's one of them that you want to write up on the board.
It's in the second quadrant. I don't know if like visually you can see that drawn that way. You know what I mean? So if you, yeah, so then that way you, for me, it helps, especially if I draw the axes, then I would have not missed that negative.
Like the X and Y axis. Does anyone want to write up the first one? Part A. Show their formula and then their answer from there. Okay. And remember when you write on there to not put your hand on it. You're good. I do that all the time. Did anyone get anything different than negative 24 over 25? Part B? Anybody want part B? Do it.
I want to do C.
You want to do C?
Yeah, I'm not gonna do-
Go for it.
I'll go after B.
Okay. Who wants to do B? I'll lean harder back. Who wants to do part C?
You can do both. That's good. Yeah, I'll do both.
Oh, it's the wrist. He can't.
That's an excuse.
Yeah, it is.
Did you do it during soccer? You don't know. Okay. Just hurts.
Mm-hmm.
Nobody wants to do part B? Melanie's about to come out of her seat. She's taking somebody. Yes.
I'm so ready.
So Carter, are you gonna take the route of the formula or like sine over cosine?
So much. It's so much.
And I can scroll up so you can have the. So how did you get the two negatives? Or how did you get two positives?
Because that turned into negative 32 or 25.
So then that should stay.
Oh, it stays.
Uh-huh.
I didn't know that.
So so 25 minus 32.
How do you typically determine which one you use for the formula? 'Cause there's three-
For which one?
There's three you can choose from for cosine.
Uh-huh.
So I picked a different one.
Here's correct. Here is the beauty of all that. You can use any of the three. The reason why we've been using just sine is because there are no mistakes in that 4/5. Does that make sense?
Like the other, it would be like a number that I got from.
Right. The other one, what if you accidentally forgot the negative? What if you did Pythagorean theorem and you did not get 3? That's a mistake that you made on your end when in reality, if I'm going to pick a formula, I'm going to pick one that there are no mistakes in 4/5. So that's why. But no, you can use any of the three. And I think, like I said, looking at that formula sheet back there, I think this is the only one they give you. So in reality, you're going to have to, which you can derive these. Remember our, I can change cosine squared to what? 1 minus sine squared. And if I have 2 of those, 1 minus 2 sine squared. Same thing, if I change this to 1 minus cosine squared, I would get that formula out of it. So these can all be derived from just this one here. So it doesn't matter which one you want to use. All right, Carter. Does anyone need to see it worked out with the formula? If you've got something different and you want to see where you made a mistake. So this is nice when this is a part of the question, okay? But if not, still make yourself familiar with doing that as well, okay? All right, any questions? All right. Guess who's back? We have more formulas now, which means we can do more identities, okay? Same thing. Once you manipulate one side, you cannot touch the other side. All right, so let's look at our options here. If I look at sine 2 theta, look how far I can get. 2 cosine sine. Can I do a whole lot with that? Can I do a whole lot with tangent?
Probably.
Yeah. Okay, go ahead and start manipulating the right-hand side. They hate these. Some people closet secretly love them though, and they won't come out and say it just yet, but they love them. I'm publicly saying I love them.
Why couldn't it be plus? Why couldn't it be minus? Why couldn't it be minus?
Do what?
I forgot all identities except for those.
Well, how can we change tangent, just in general? Sine over cosine. Try that.
Yeah, I didn't think of that.
Well, I like it. Well, we should go to the bottom one though. It's square, right?
You can still do it. It'd just be sine squared over cosine squared.
Are the whiteboards coming back?
Not for this lesson.
No.
Do you feel like you need it?
No.
If you need a confidence boost, you can do the second one pretty quickly.
That's not something constant boost.
I know y'all can't skip, but the second one's a lot easier.
Maybe.
Remember, the only questions you can ask is it legal? Am I on the right track?
Am I on the right track? It's that bottom line.
Yes.
Wait.
So what were our, what's the word I'm looking for? I keep thinking methods of madness, but it was, what's the word I'm thinking of? I need you to get inside my head for a minute.
Can you describe the word?
Approaches.
Okay.
There it is. Okay.
I
What were our 3 different approaches?
change everything to sign and propose sign,
Uh-huh.
foil or.
Foil or factor, yeah.
It's probably one of these guys.
It is the one you need.
Did I write it down in my notes?
Think about
What was the first one you
fractions.
said?
Fractures?
No, it was change everything to sine and cosine. And then he actually gave me the 3rd one, which was factor foil. What was the one in the
Ooh,
I'm not really on those.
it was fractions?
What would that have to be? I don't know.
adding and subtracting fractions? What do you have to have?
Common denominator. Hey, am I on the right track? This is on the right track.
This is your.
I'm dividing, so it's this over this.
So then one of,
I turned one into maybe the square and put
No, because they can do
Which
that.
is- what's that?
sine squared.
I don't think.
Oh, I got, oh, wait, hold up. I didn't think of that.
that was a good one, isn't it?
Oh, it's not in here somewhere. It's in.
Cosine 2k equals cosine squared theta minus sine squared theta. So plug it
It's in two.
and then sine squared is cosine.
Oh, you know, proofs on the homework?
On the homework?
Yeah. Or
Like
is this
tonight?
just like a, or is this just like a thing in the notes?
I don't remember.
Say it.
I know you have them on the test.
Wait, aren't those like from the first set? From like what we did the first day?
Yeah, they're not extensive.
How many are gonna be on the test?
2.
Okay. Well, it's 2 questions I'm gonna get wrong.
No.
I'm gonna spend the rest of my test working on the other problems.
And then come back to them.
Spend the last.
Right.
You're gonna see math you've never seen before.
Trust me, it takes me, like, y'all are used to me getting test grades back to you really quickly. Ain't gonna happen on this test, cause I have to follow all the things.
This radar?
I'm gonna play some Miss Radar math where some numbers are just gonna disappear.
This radar, what a name.
Well, that wasn't her name.
That was her
Oh,
name.
that was her nickname that y'all gave her.
Miss St. John, her child had Bones disease, so she was out for the last 3 weeks of school. And we had a substitute named Miss Rader who
Oh,
taught math, but whenever she tried to do stuff, she blamed calculators for being wrong. Numbers disappeared off of her equations, and yeah, so we
Huh.
named her Miss Radar and hated her.
I thought for some reason.
I had a friend,
I had a fun time.
Raider, his last name was Raider, cause we called him Raider, but my mom would always change it to Radar as well. And now he works in the White House.
Well, White House?
We're just gonna skip past that one?
Yeah, we're gonna just skip past that. Elections change. Let's see, I think he was on the, I can't remember if he is still there or not.
Oh, wow, that was really easy.
Oh, there we go, finally.
Alright, there we go, we waited long enough.
I definitely got it right.
That was really easy.
Absolutely.
What, this, number 7?
Sure, I mean.
I didn't know this exact.
I didn't even start.
The little freedom.
That's what
Number 17.
Oh, why did I?
Alright, so, yes. Yeah, you can go ahead and change that to a 1. It's so funny because it's like you skipped showing from here to here, but then you showed a line going there to there. Yeah, you're good.
It looks.
Okay, so 2 sine theta over cosine theta. And if we get a common denominator here, then I'm gonna, just because I don't have enough space here, I'm gonna go ahead and multiply by the reciprocal. Okay, you turn 1 into cosine over cosine, or cosine squared over cosine squared. Here, let me show it. All right, so if I change it to cosine squared, whoops, I don't know why I did that. So cosine squared plus sine squared all over cosine squared. All right, so I got a common denominator. But then cosine squared plus sine squared is what?
1.
1. So then that becomes cosine squared theta over 1 if we multiply by the reciprocal.
Would that be the 1 plus cosine squared?
It became cosine squared over cosine squared.
Oh.
So then one of my cosines cancels with that one. And 2 sine theta cosine theta equals the sine 2 theta that we were looking for. And I would write that at the bottom, but I want to be able to see that.
That's basically what I did.
It is what you did.
Well, basically, I mean, I did a little bit different.
Okay.
I know I'm processing numbers, but I got that issue. I got like sine plus 2 sine squared plus cosine squared. And I just like kept those stuff out, and I got it.
As long as it's legal, there are you. Go about doing it.
It's not fully legal.
Not completely legal. All right, so on number 7, like I said, that one's a little bit more straightforward. I can look at the fact that I need just cosine in the end. In other words, I need to get rid of sine, and this formula does that for me. So if I write sine squared theta, or x in this case, plus cosine squared minus sine squared, then that cancels. Whoops, that's a cosine. So cosine squared x equals cosine squared x. That one was more straightforward. Okay. Questions so far? Yeah.
Oh yeah, for that one, number 7,
Uh-huh.
I moved the sine squared x to the other side, so it was cosine 2x equals.
So you can't do that.
I can't do that.
You can only manipulate each side. You cannot do an opposite operation to move it over.
Okay.
How does the cosine 2x become cosine squared?
So this right here
Yeah.
becomes all of this because of that right there.
Fine.
So I just, instead of writing cosine 2x, I write that whole thing in there. Other questions? Okay. Let's do my favorite one.
That was a pretty good number. I don't know how they did it, man. It's pretty good.
page. I just love studying.
I'll give you a hint. You'll need the formulas from the other day as well.
Which other day are we talking
This
about?
is like
Last week.
class 4?
Yeah, we're talking about class.
Yes.
There's not.
I don't remember this.
That was like a really long time ago.
It was a pretty.
It was a very long time ago.
A lot happened. A lot
Good
has
thing
happened.
you have notes to look it back up, right?
I'm not back with it.
Ah, man.
It's your fault. I don't know how, but
Signed.
maybe for the.
Those signed by folks. What? Cute? I don't believe it.
Anything bigger than 2 is kind of a no-no.
I actually like it. Yeah, it's caught up.
I think David's got it. David's retired. He's retired from school.
I got like.
What's the point of proof? Why do I need to prove you this equals that?
Yes.
I need.
It just does.
Listen, I had to prove why 1 was bigger than 0 in college,
Yeah, I can count them.
Well,
right?
Seems simple. That's easy to prove.
How long did that take?
Right?
How long did it take?
It was like a paragraph.
paragraph.
Like a math or like an explanation, like writing it out?
I would have just written one sentence. Google number line. There you go.
No, I want to put duh, period.
I was
She could Google it that time.
Zero.
What? Google wasn't a big one when she was in college.
Google might have been.
That was like 50 years ago.
I'm trying. I think it was a thing.
You calling her old?
No.
I'm not
Google was a
50
thing in
years old,
2004.
and it wasn't 50 years ago. It was a
Same
while
thing.
ago.
Google
It was
wasn't
born like 5 years ago.
Instagram wasn't a thing. Facebook was barely a thing.
MySpace.
MySpace.
I did not have a MySpace.
Come on.
I know.
I thought MySpace was a big thing.
It was, but it wasn't for me. Like I was in the weird gap of like,
She was a math nerd.
that wasn't.
Sorry.
No, I wasn't. I was in the weird gap of like, cause like AOL Instant Messenger was still like really big but then at the same time I wasn't
You've got math.
old enough to have a MySpace, but then I was able to have Facebook when it came out. Like it was like that, my age just kind of fell in that. But no, I was not a math nerd.
You
Then-
like
I
proofs.
don't know, man.
You
Yeah,
like
you like
identities.
proofs.
I mean, your future career. I mean, I guess your current career now, but your future career.
I
from that
took
moment.
CP pre-cal in high school.
So,
Yeah, okay with that.
That's
Just
it.
like
Okay,
math.
now you're teaching. Now you're teaching the pre-Cal.
Right?
Yeah.
I think that's pretty math nerdy to me.
I had a professor.
I agree
No.
with this statement.
You like math. I like easy math. I like math. that-
Why'd you bridge math?
I don't like this math.
I like everything about this math except proofs.
I still don't know what
Proofs
it
is
is.
just
I hated
It's
math
like
ever
that they're
since.
puzzles. They just.
It's a crappy
I
puzzle.
disliked every single
I've
thing
been
we've done about
staring at that.
Puzzles
He
give you
knows.
hints and pieces.
I gave you a hint.
No, you gave me the picture. I don't know. No, I want the.
I gave you a
I have to
hint.
make I have to make my own puzzle pieces. That sounds like bullcrap to me.
I love how y'all just came alive after Miss Wash left.
Math was fine until trigonometry.
I know, I'll be like,
That's
let me
what
press
it was.
play on what you missed here.
Oh, I forgot this is recording.
Math is kind of.
I'll find Miss Radar too.
The last.
That's okay. She doesn't even remember me.
Yeah.
Oh, look, she's got enough gray hair.
Ratio.
Hey, I have gray hair,
No, like I mean, it's like she got the.
but that's
grandma-
also from teaching and having a kid. You grade a lot
She's just
faster.
got grandma hair.
Good morning. Could Kayla Webster, Jennifer Galloway, Norman Williams, Daniel Sharp, and Jessica Gribb please come to the front office?
Ooh, the teachers are getting in trouble.
All the teachers.
I have Jessica Grizz. Okay.
Okay.
No.
So, gave you a hint.
What's the hint?
I said to use the formulas from before,
I
so
looked
go ahead.
I know what he's doing, I think.
Oh, I'm like. had to-
Go ahead and
Yeah.
write that out. Follow the formula from the other day.
Is that supposed to be plus theta or plus zero?
That's a theta.
Okay.
It's there somewhere. Now it looks like a baby with a toboggan on.
Good.
Be very familiar
Speaking of baby, Chase turns 11 months tomorrow.
That's like
when he hits 1 year old, are you gonna stop being like, oh, he's 13 months old?
Oh, 100%.
Oh,
Yeah, no, from here on out, he's 1, he's 2, he's 3,
He's alive.
I'm not like,
people,
he's 17 and a half
Yeah,
months.
that's
He's
what
been
I see
alive for a
parents do
period of
that on
time.
like TikTok and it bothers me so much. Just
Yeah.
say
My
you put it
child
on
is
an internet.
47 months old. What?
Yeah, no, I'll stop after the,
3 years, 11 months. Maybe can count.
Babies like talk at 18 months, isn't that a thing?
it depends. Chase currently sings.
That's not.
Does it sound like Am I Singing Monsters?
Crawl at 11 months?
A lot of that.
Monsters.
Yes, he is crawling.
How long does it walk?
It just depends.
My baby
Babies are so different.
I know, they are so
It should be
different.
standardized.
Babies are whack.
They should be standardized.
My
Standardized tests,
I say we do it like the Romans.
No, mine's gonna walk.
10 months.
He's gonna take a stroll.
Just toss him.
It's gonna drive, it's gonna drive your wife.
All right, so if I rewrite this, are y'all with me?
Yeah.
I can't wait for whoever is missing class and all my other classes to
Just
Get
stream the
to-
video.
listen to this video.
I think you just cut the video.
They probably fast forwarded.
They 100% did. Because I did that. That class. What? Alpha 2. Yeah.
I kinda never did that.
Were you guys in the shadow browser?
I don't think I've ever missed this class.
I've missed it.
If I missed that.
I missed back in turn.
Yeah.
Oh, I didn't pay attention to that class. It was all online, it was all on Delta Maps.
Yeah.
I've
Took
never
your
done
notes and it didn't
Delta.
listen.
I remember that.
That was fun.
Yeah, I did a few of it during COVID year, but not crazy. All right, so, look what I need to have in the end. I need all cosines. Okay, so if I need all cosines, and I don't need a cosine 2 theta, and I don't need sine 2 theta, and I don't need sine, I need to look at these to get me there. So if I think about cosine 2 theta, again, I just need cosine, so I'm not gonna use this one, I'm not gonna use this one, I'm gonna use this one.
Okay.
So this becomes 2 cosine squared theta minus 1. Hey, if y'all won't take this one seriously, I might put it on the test. Good one.
Put this exact problem in the test.
Yeah, what is the exact problem?
Hey, I had a professor that did that. All his proofs were the same exact ones he did in his notes during his lectures, and so I would just write them over and over and over and over and over again until one test he did not do that.
And then you failed it.
We all failed.
Nice.
So then I can change sine 2 theta to 2 cosine theta sine theta, but it's still being multiplied to that other sine theta.
How what? You just make that.
No, I changed that to that.
Yeah.
Now I'm gonna distribute my cosine. Whoops.
Oh, there's a plus on
Again, my whole goal is to not have sine in there anymore. I just need cosine. So I'm gonna change sine squared theta to what? Good. Distribute. And then combine my terms. So then I get 4 cosine cubed theta minus 3 cosine theta.
What if I did this up to the other side? Instead of starting like this, cosine 30 theta. Because I did it on the other side, and it didn't really work out. It kind of worked out.
It really didn't work out, but it kind of
Well,
worked
I
out.
got like 3 cosine, not like simplifies to cosine cubed.
I don't think that I've ever worked from the other side just because there's no way to, like, there's no formula for cosine 3 theta.
I split it apart. So I did 2 cosine times 2 cosine squared minus
Can we never do that?
cosine times 2 cosine, and then I like what's in there. Wait, no, I got the answer right eventually.
If I see that as a problem,
Yeah.
on the homework, I'm gonna write as many digits as
Yeah,
I
I can-
can now.
What is a challenge test?
I'm not gonna do that.
What's the point?
Only one kid passed it.
That's not true.
I completely
Yes.
forgot.
Oh, Vine's class.
What is like, if you pass the challenge test, what does it do?
So if you pass the challenge exam, you get a college credit, like hours towards that. In the past, it hasn't really counted in the grade that you have, and kids knew that, and kids didn't, so it now counts.
It counts?
It counts. If I get like an F on that, that means I gotta make an F in class.
We're not gonna get Fs on it. We're gonna do great.
But theoretically.
But yeah,
it did happen.
Theoretically,
How much does it work? Like,
It's like.
15%,
Like what?
like a final would be.
Right.
But you get the 4 points added.
No one passed it though.
That's not true.
Like 2 people will.
Trust me, you'll be fine.
Statistically, none of us will.
I will review you like crazy. You'll be fine.
That's
So much fun. Sounds like a great time.
They used to give us like a 17-page packet.
Oh, my teacher did last year. We had like a 13.
I used to do that for the old state test, but not this one. Okay, so this is what I was talking about with half angle. Let me show you this one real quick and then we'll be done. Sine 22 and a half. So we talked about how we can make that sine of 45 divided by 2. So if you notice on these formulas, we have plus or minuses. Well, what are we evaluating? Okay, what quadrant is that in?
One.
So then it's a positive. That's what the plus or minus is if you have to determine what you're actually evaluating, so then that determines if it's plus or minus. Okay? So we have the square root of 1 minus cosine of 45 divided by 2. Again, setting things up is huge on this test. I at least know that you know how to set it up. Do you know how to finish it off from there? That's a different story. So cosine at 45. Go ahead and reduce that. I'm gonna change my 1 to 2/2. Multiplied by the reciprocal. Thankfully, that gives me 2 minus root 2 over 4. Because then I don't have to rationalize the denominator. Because there will be some that you will have to. Because the square root of 4 is just 2. And yes, you can have a radical inside of a radical. Questions?
How did you go from over 4 to over 3?
How did I go from here to here? There to there? Okay, so I can put a radical on top and a radical on the bottom, and the square root of 4 is 2.
Oh,
Yay. I love math.
Me too.
Math makes me happy.
Me too.
Good luck yourself.